For Section 6, Formalizing Relations and Functions, Part 1. Domain and range. A relation is a pairing of numbers. The domain is the set of x coordinates of a relation, and the range is the set of y coordinates of a relation. This is something that just has to be memorized, is that domain is the set of x values, range is the set of y values. The way that I remember it personally is that if you think about domain and range in alphabetical order, domain would come first and then range. And if you think of x and y in alphabetical order, x would come first and y. So if you match them in alphabetical order, the domain would be with x and the range would be with the y. That's just a little trick that helps me remember which is which, and it could be helpful to you also. The main thing is you just need to know that the domain is the x values, the range is the y values. However you remember it, it's not important. The thing that is important is that you do remember it. A function is, if you remember, we've talked about functions before, but a function is a special type of relation in which each value in the domain has exactly one value in the range. And we've talked about this before, and we've said that each input has exactly one output. Remember, input had to do with x's, output had to do with y's, just as domain has to do with x and range has to do with y. So we can just say a function is in a different way. We can say that a function is a special type of relation in which each value in the domain has exactly one value in the range. The first example asks us to identify the domain and range in each relation, represent the relation with a mapping diagram. Is the relation a function? First of all, we are given a relation. If you notice the little squiggly like parentheses, that's going to show us the relation that we're talking about in a relation. If we identify the domain, we're just going to list the x values. So the domain we would write as -3, 0, 1, and 2. And then the range, we're going to list the y values from the ordered pairs, which are 1, 2, and 4. Notice for the range, there are two y values in the coordinates that were given. There are two y values that are 1. We don't need to list both two ones. We just list one. You don't need to repeat numbers in the domain and range. And you also write the domain and range. You write them in order from least to greatest. We haven't talked about a mapping diagram yet, but I'm gonna show you a mapping diagram right now. To create a mapping diagram, you're going to have a column with your domain values and then another column with your range values. A mapping diagram is going to draw arrows from the domain value to the corresponding range value. So if you look at the first ordered pair in question A, the first ordered pair is -3, 1. So we need to draw a line from -3 in the domain to 1 in the range. The next ordered pair is 0, 2. So we draw a line from 0 to 2. The next one is 1, 1. So we're going to draw a line from the domain value 1 to the range value 1. And then the last one is 2, 4. So from domain value 2 to the range value of 4. If you remember, what it just said is that a function a relation is a function when each domain value has exactly one range value. So for each domain value, -3, 0, 1, and 2, there's only one range value matched to each of those. Because each domain value has one range value, we can say that the relation is a function. Notice that the range value 1 matches with the domain value -3 and the domain value 1. That is okay. It's just the domain value that can't have two range values assigned to it. So this mapping is okay. It does show a relation that is a function. The next example says to identify the domain and range of each relation, represent the relation with a mapping diagram. Is the relation a function? Just like with the last example, I'm going to go ahead and write the domain. I just look at the numbers, take the x values, which are 4, 5, 7, and 5. Again, I do not have to repeat the 5. I'm just going to write it once, even though there's 2 domain values that are 5. Write them in order from least to greatest. The range values are 6, 1, 2, and 2. So I'm going to just, again, write them in order from least to greatest, and I don't have to write the 2 times. I just write it once. For a mapping diagram, I'm going to have a column with my domain values and a column with my range values. Just like before, I'm going to draw an arrow from the domain to the corresponding range value. So the first ordered pair is 4, 6, so I need to draw an arrow from the domain value 4 to the range value 6. For 5, 1, I would draw an arrow from 5 to 1. For 7, 2, I'm going to draw an arrow from 7 to 2, and then for 5, 2, I would draw an arrow from 5 to 2. If you notice in this mapping diagram, the domain value 5 has 2 arrows going from it. One is going to range value 1, the other is going to range value 2. Because the domain value 5, it has 2 range values, 1 and 2, the relation is not a function because one domain value 5 has 2 range values. There's arrows going from 5 to 1 and 5 to 2. So this relation is not a function. The vertical line test, another way to determine if a relation is a function, is if a vertical line passes through 2 or more than 1 point of a graph, then for some domain value, there is more than one range value, so the relation is not a function. So before, when we were given ordered pairs, we could do a mapping diagram to figure out if the relation was a function or not. If we're given a graph or points that we want to plot on a line, or on a coordinate plane, then we can use the vertical line test. Remember, a vertical line is a line that goes straight up and down. Examples of the vertical line test, where I'm showing you 6 different graphs of relations. The vertical line test is we're going to pass a vertical line across the graph. If you notice on that first example, if I went back, watch the pink line that's going to go across the graph, and at no point on this graph does it hit more than 1 point at a time. So this relation is a function. If you look at the next example, watch it as it goes across, and as it goes across, there are several points where it's hitting more than one spot on the relation that's shown. So in this case, it does not pass the vertical line test, so it is not a function. The next example, if you watch it carefully, at no point does it cross 2 points, so this one would be a function. If you go down to the bottom left, we're going to pass this vertical line through the graph, and at no point does it hit more than 1 point on the graph, so it is a function. If you look at this next example, though, was it passes right through there, through the middle of the graph towards the y-axis, or if you even just look at the y-axis is cutting through 3 different points on the relation, so this is not a function. And then the last one would be a function because at no point does it cross more than 1 point on the graph. The next example says, is the relation a function, and use the vertical line test. Before we can use the vertical line test, I need to plot my points and then connect them. So we're going to have -4, -4, -2, 3, 3, 0, 5, 1, and 6, 1. I need to connect these points, and then I'm going to take a vertical line. Something that you can use for a vertical line that you should have in front of you when you're working on math problems is a pencil. If you just take your pencil and you make it vertical and pass it through the graph, if you did that to this graph, at no point when it passes along through this graph, through this relation, does it pass more than 1 point. So the answer would be yes, the relation is a function. The next example again asks, is the relation a function? Use the vertical line test. It gives me an equation. So I need to go ahead and make a table to find ordered pairs that I can plug in. When I plug in -2, my y value is 9. When I plug in -1 for x, my y value is 3. When I plug in 0 for x, I get 1. Plug in 1 for x, I get 3 for y. And 2 for x, I get 9 for y. Go ahead and plot the points that you were just found on your graph. Connect the lines. Because I have an x squared in my equation, or the function that I'm trying to graph, it is going to be a parabola, if you remember from yesterday's assignment. I'm going to go ahead and take a vertical line and pass it through my graph. If at any point this crosses more than one point on the parabola, then it would not be a function. But in this case, it did not pass through more than one point. So the answer would be yes, the relation is a function. Function notation. You have seen functions represented as equations involving x and y, such as y equals -3x plus 1. You can write this equation in function notation by changing out the y and writing f parenthesis x equals -3x plus 1. This f parenthesis x replaces the y and it is read f of x. So instead of f parenthesis x, I would read this as f of x equals -3x plus 1. Really quickly, and I don't have this written down on this slide, so listen carefully. If I wanted to plug in, let's say 6 for x, I would plug in the 6 into the parentheses of f and then parentheses 6. That would mean that I want to substitute in 6 for x, the variable x. So I would plug in -3 times 6 plus 1. Just quickly, I don't have it written down. It is a part of the next example, but I wanted to make sure that I had said that also. So this would be read f of x equals -3x plus 1. F is not a variable. That is very important. F is not a variable. It is the name of a function. So f of x doesn't mean f times x. F is naming the function, and then x is the variable. Function notation is used to emphasize the value of f of x depends on the independent value x. Other letters besides f can be used, like g and h. So sometimes it won't be f of x, it'll be g of x or h of x. It just depends. It could be any letter. Usually you're not going to use an x or a y, though, because those are our common variables and the axes of a coordinate plane. The last example says the function t of x equals 65x represents the number of t of x words that Rachel can type in x minutes. How many words can she type in 7 minutes? So if x is representing the number of minutes, I need to plug in 7 for x. To do that into function notation, I'm going to say t of 7 equals 65 times 7. Notice I've plugged in 7 into the function notation to write t parentheses 7 equals, and then I plug it in for the variable x, 65 times 7. When I multiply 6 times 7, I get that Rachel can type 455 words per minute. Today's assignment is on page 289. It's numbers 1 through 20 all.